Lesson 5 is called direct variation. Direct variation is a relationship between two variables in which one variable is a constant multiple of the other. Okay, that doesn't make a whole lot of sense at first, I know. So this is almost like a definition that I need you to understand. Direct variation, down here, this is a graph of a direct variation. So what you're going to see is a straight line. And you're also going to see what's really, really important is a direct variation starts at 0. So this is the origin down here, and that's where, so this is 0, 0. That is where the lines start. 1, 2, 3, 4, 5, because we're looking at our x-axis. Remember, whatever you come to first is the x. That should always go along the horizontal axis. This first column, whatever you come to first, that is your independent variable, and then your dependent variable comes next. So it looks like going up the side, it's really good. What I'm doing right now is I'm trying to figure out what each square is worth. So just be careful. This square was 1, 2, 3, but when I go up, if that's 20, this must be 10, 20, 30, 40, 50, right? The squares don't always have to have the same scale on the x-axis as they have on the y-axis. So it's really important to notice the scale. A lot of students will say this is 1 and this is 1, and they don't pay attention to what's actually written there. So what we see here, we have time and distance, and it's graphed over here on the right. So this is the big deal about a direct variation. If the time is 0, the distance is 0. So if somebody is going for a jog or something like that, if they haven't started yet, the time is 0. They haven't even started. They haven't gone any distance. So that is a direct variation graph. What I do see here is that every time I have a number on the left, if I multiply it by 10, I think you might be able to see, I end up with what I have on the right. So we have a multiplier number, I guess you could call it. So this is a direct variation where even if I look over here, if 1 second has passed and I follow that up, that's 10 meters. Something called the slope of the line. How steep is the line? So right here, let's say at this point, if I imagine looking down this way, whoops, I know that that is 50 units tall, and I know going across, that is 5 units across. So for 50 meters, if I divide by 5, I get 10 meters per second. So this is the rate that they're going. If I took 30 and divided it by 3, I would get 10 meters per second. So that 10 is showing up in the graph, and it shows up over here in the table. It's the number that you'll see in this formula. So this is going to be a really important formula for us. That m is where the number 10 would go in. So when I see this formula, it doesn't really matter what the variables are, but distance equals 10 times the time. That's what that is saying. Y equals mx. This is where I put my rate or my constant of variation in. So this formula, there's always going to be a number beside the variable. And the number that you see there is the slope of the line or the rate, but it's also called the constant of variation. So right now, constant of variation, it's often represented by the letter m, and it's also known as rate of change or slope. I think most often I'll probably call it the slope of the line. So how steep is this line? Well, if we go up 50 meters, it takes 5 seconds. So we're looking at how steep that point is here compared to here at the beginning. So this is our slope that we find is 10. So the graph of a direct variation is a straight line that passes through the origin. I know these are a lot of new words and it sounds a little weird at first, but the more that we use these words, the more comfortable you will get with them. So, for example, for each of the following, determine the constant of variation. That is the same thing as the slope or the rate. So one thing I know that we talked about when we talked about ratios, we studied the unit rate, but it was back in a review that we did at the beginning of the course. You might have studied that in grade 7 or 8. That's how much is it for one? How far do you go in 1 second? How much is it for one book? So the unit rate is always per one. So that's what this constant of variation is. So the total cost varies directly with the number of books bought. 5 books cost $35. Okay, we don't care really how much 5 books cost. I want to know how much is one book. So if I think you probably know, you take $35 and divide it by 5. I'm getting that we have $7 per book. So this is our rate or our slope. So when we go to write our formula, total cost is equal to $7 per book. So if we buy one book, it's just $7. If we buy 2 books, 7 times 2, that's $14. If we buy 3 books, right, we would be able to sub in the number of books. That's where it would go. So if somebody bought 5 books, that was $35. That's where it comes from. This is our general formula for our equation of our line. This is our rate for one book. It's $7 for one book. So look at example B. The volume of water varies directly with time. A swimming pool contains 500 liters of water after 5 minutes. So the swimming pool is being filled 500 liters every 5 minutes. Well, that's awesome that it's every 5 minutes, but I want to know how much is it going up per minute. So when I divide those, I get 100. That's 100 liters per minute. That is our rate. So if I need a formula for this, I could do volume is equal to 100 T. So T could represent the number of minutes. If it's 5 minutes, that's how we'd get 500. If it was after 1 minute, it would only be 100 liters. If it was 6 minutes, it would be 600. Now these letters don't matter. I'm just using V for volume, T for time. You can always just use Y equals 100 X every single time. You could use a Y at the front and an X back here. That's pretty standard. If you don't want to have to think about what letters to use, the letters really don't matter. So what is important is that the rate has a letter beside it. So let's look at this. Complete each table based on the information from example 1 above. Then sketch each graph. State the independent and dependent variable. So whatever you come to first would definitely be your independent, and the cost would be your dependent. I think that makes sense, right? Doesn't the cost depend on the number of books you buy? The number of books doesn't depend on the cost depends on the books. Over here, the volume of water depends on how many minutes have gone by. So the volume is dependent, the time is independent. So for 0 books, how much would it cost to go into the store and buy 0 books? Hopefully it's going to cost you $0. To buy 1 book, we set up above that the cost is $7 per book. So 1 book must just be $7. If I buy 2 books, I'm subbing it in for the B. 7 times 2 is 14. And right away you might notice these are going up by 7. 3 books would be 21, 4 books would be 28, and 5 books would be 35. And they all go up by 7 every time. There's very much a pattern here, because we're talking about a linear relationship. Over here, we had a formula that was the volume is 100 liters every minute. So if 0 minutes have gone by, there's no water in the pool. If 1 minute goes by, I would sub a 1 in here. That would be 100 liters. If 2 minutes go by, that's 100 times 2 is 200. If 3 minutes go by, we've got 300. And I think you just from there, you know there's a pattern. and they're all going up by 100. Okay, we can also multiply this number here by 100, 2 times 100, 3 times 100, and that is our constant of variation, or our slope. When we look down at the graph, remember that whatever you come to first, the number of books has to go in the denominator and the time has to go in the denominator. So I have already graphed this. I have independent variables on the x-axis, the horizontal axis, and dependent on the vertical axis. I'm going up, the number of books was 1, 2, 3, 4, 5. The number of minutes was 1, 2, 3, 4, 5. I had cost, and we were going up 7, 14, 21. So I went up by 5s because I had to go all the way up to 35 for my graph. And I had to go up to 500 over here. So I'm trying to space it out as best I can. So I have 100, 200, 300, 400, 500, and 5, 10, 15, 20, and I counted by 5s. So when I plot my points after one book, it's going to cost $7. 2 books is $14, and I'm just doing my best to get the points in the right spot. This is a linear relationship because every single number of books goes up by $7. When I look at this point here, if I took 35 and divided it by 5 books, I get 7. So these are $7 for every book. On the right here, I'm going to plot my points 100, 200, 300, 400, all the way up. But after 1 minute, if I take 100 divided by 1, I get 100. If I take 500 and divide it by 5, I get 100. And 100 is the constant of variation, or the slope of the line.